Hello students, let us verify isosceles triangles theorem using Geogebra. First of all, let us have the statement of this theorem. The statement is, if two sides of a triangle are congruent, then angles opposite to them are also congruent. This is isosceles triangle theorem, and this is about a triangle whose two sides are congruent. Now let us try to illustrate this by using a diagram. Suppose we have triangle ABC as shown in figure. Side AB are given to be congruent to side AC as they are shown by similar symbols, by the same symbols. So in this case, in triangle ABC, side AB is given to be congruent to side AC. If it is so, then angles opposite to them are also congruent. That means angle opposite to AB is congruent to angle opposite to AC. And angle opposite to AB is angle C, and angle opposite to AC is angle B. So in this case, angle ABC is congruent to angle ACB. Angle ABC is congruent to angle ACB. So this is the property we are going to verify using Geogebra. So for that, let us move to Geogebra interface. This is the Geogebra interface. We have to verify isosceles triangle theorem. For that, first of all, we should draw isosceles triangle by geometric construction. So let us have the base of isosceles triangle. Let us draw a base of one segment. Let it be 6 units. So this is segment AB, which will treat as a base of isosceles triangle. Now we have to take any point above segment AB such that it must be equidistant from point A and point B, because we need isosceles triangle and we know that two sides of isosceles triangle must be congruent. So to have an isosceles triangle, we must have one point above the segment AB such that it is equidistant from point A and point B. So for that we use the perpendicular bisector, because we know that any point on perpendicular bisector of a segment is equidistant from two endpoints of that segment. So we'll draw here the perpendicular bisector of segment AB. So for that, we'll click on perpendicular bisector. We have to draw the perpendicular bisector of segment AB. That's why first click on point A and then click on point B. We get one line which intersects segment AB, which is the perpendicular bisector of segment AB. Now we can take any point on this line. So click on point icon and then click anywhere on this line to get point C. Now this point C is on the perpendicular bisector of segment AB. That means it must be equidistant from both of these 2 points, that is point A and point B. Now if we join AC and BC, we get triangle. So for that, let us select the segment icon and we have to draw segment CA. That's why firstly click on point C and then on point A, get segment AC, and then click on point C and on point B to get segment BC. So this is our triangle ACB, which is isosceles triangle as AC is congruent to CB. As we can see here, the length of AC is denoted by H and length of CB is denoted by small letter I, and the values of both of these variables are 5.9. That means these two sides are congruent. Therefore, triangle ABC is an isosceles triangle. Now we have to verify that angles opposite to congruent sides are congruent or not. Means angle opposite to side CA is B and angle opposite to side CB is A. So we have to verify whether these two angles are congruent or not. So we'll measure these two angles. So first of all, we'll measure angle A. For that, click on angle icon, then click on point B, then on point A, then on point C. We get the measure of angle BAC is angle A, which is 59.44 degree. Now similarly, we can measure angle B. For that, click on point C, then on point B, then on point A. We get the measure of angle B as 59.44 degree. So as we can see here, the measures of both of these two angles are equal, that is 59.44 degree. We have verified here that the angles opposite to congruent sides are congruent, which is an isosceles triangle theorem. That is, if two sides of a triangle are congruent, then the angles opposite to them are also congruent. I hope you understand this concept. Thanks for watching.